Good mfana boss. So halala right now. So today's session, of course, is going to introduce us to the concept of position or displacement, and of course the concept of distance. We're also going to talk about the concept of average speed, average velocity. So those are things we are going to talk of and about in today's session. But remember that we had an activity in the previous video whereby, of course, we had to answer the activity number 1, 2, 3. So they say here, in your own words, you have to explain the difference between a scalar and a vector. And I said you can't go to the physical sciences examination without knowing what is a scalar, what is a vector. So remember that by definition, when we talk about a scalar, we are simply talking about a physical quantity with magnitude only. Whereas when we talk about a vector, we are talking about a physical quantity with both magnitude and direction. So already we've explained the difference. Of course, there's no way we cannot mention those two: magnitude for scalar, magnitude and direction for vector. Now list two scalars and two vectors that are commonly used in statics. Now remember I said that for these physical quantities, we must be able to identify whether they are scalar quantities or they are vector quantities. So halala right now. So now in question 2, they say, okay, there are quite a lot of physical quantities that we can use in statics, which I've explained to say it's a science whereby we are talking about objects that are stationary, objects that are not moving. So list two scalars and two vectors that are commonly used in statics. Of course, time. Whether you are moving or not, time is moving. It doesn't come fanabo. So why bonata? So when we talk about time, of course, it will be the scalar that we can think of and about. Perhaps because we have an object, but that object is stationary. That object is not moving. Therefore, we can maybe talk about mass to say, well, mass is another solution that we can think of and about of scalars commonly used in statics. So of course, we've said for number 2, this is what we have. We can talk about the mass, we can talk about the time. So those are the two scalars that we can think of and about. So halala right now. Now what vectors can we think of and about? Well, perhaps force. Because in order for motion to happen, or even for the object to stay stationary, there are forces there that are balanced. So definitely we can talk about force. We can also talk about perhaps displacement. To say the object has a zero displacement, it's not moved. So that is what we can think of and about here. So halala right now. So those are the solutions that we can think of and about here for question 2. For number 3, however, we are saying determine whether the following quantities are scalars or vectors. And I said it bazo bozange exam so halala right now. So you are given 30 kilograms. You know for sure that only here I'm talking about a mass. So this will be a mass. So definitely mass is a scalar quantity. 30 kilograms is what we are interested in as a mass under physics. Now we're having 4 meters. Perhaps 4 meters could be the measure of distance, because they didn't say anything about the direction. So we will say 4 meters and we'll be done. So halala right now. So distance definitely is also a what? Is also a scalar. So now here they say 30 newtons down. So when they talk about 30 newtons down here, it seems like they are talking about force. So definitely force is a vector quantity. And then of course 60 seconds is time, and time is a scalar quantity. The last one says that a force of 80 pounds applied at 45 degrees. So the fact that they've given us the direction here to say it is applied, this particular force, and they say it's a force, it is applied at 45 degrees. Therefore, it definitely will be a vector quantity, because there is the presence of magnitude and direction. So halala right now. Now, of course, we've mentioned that in actual fact, when we talk about mechanics, we are all interested in nothing else but, of course, the motion of objects. Now, there are quite a lot of physical quantities that we can talk of and about here, of course, under this motion of objects. When the object is moving, as physicists, there are quite a lot of things that we have to think of and about. Well, we can think of the following. Let's find out. We can think of course, the position. So that is what we can think of. We can think of the position of the object to say, okay, here is this object, here is that object. I don't know if you get what I'm saying, boss. So we can think of position to try to describe the motion of objects. We can try to think of distance to say, hey man, for me to get to Wendywood High School from Bramfontein, the distance I travel, halala right now, traumatic. So those are some of the things that we can think of and about. Of course, as we advance our knowledge, of course, under mechanics, motion of objects, we will of course start now to introduce ourselves to the following things, such as speed, things such as velocity, and we will of course perhaps talk about acceleration as well. Now, if you are aware here, we are having position, we are having distance. Those are physical quantities. Now my question is, can you identify whether they are scalar quantities or vector quantities? I wonder. So what we learn, of course, already is that when we talk about position will be a vector quantity. We will try to see why is position a vector quantity. Distance, of course, is a scalar quantity, because we are only interested in what? We are only interested in the magnitude, the size. So speed, of course, will be a scalar as well. Whereas, of course, when we talk about velocity, we will talk about vector, V for V, S for S. Vector is a velocity, or velocity is a vector. Rather say it that way. So, halala right now. So now what we're going to do at this time and moment is to try to focus, of course, on these two concepts, which is position and distance, to try to see what is the difference between position, which we sometimes refer to as distance, or rather displacement. So displacement, distance. Let's start with that, and we'll advance our knowledge, of course, in physics, the study of behavior of matter. So usually what makes learners lag behind with physical sciences is to think that physical sciences is just a subject to pass. And in actual fact, when we are being realistic, physics is an object, or rather physics is a subject to pass, yes, but it's also a subject to apply, because it applies in your everyday life. For instance, let's say here is your home, very beautiful, and now here is the school that you come to, Wendywood High School. Let's name the school Wendywood High School, or Wendy. So this is the school, of course. Now what is going to happen, of course, is that the motion from your home, of course, from this point here to here, of course, is what we will talk of as being displacement. Usually displacement we use delta x, but we'll talk about that in a moment. So if you are aware here, displacement or position was only interested in your initial and your final. It was only interested in your home and the school. That's just what it is interested in. So here we have the initial, here we have the final. That's just what we are interested in, and we'll try to explain displacement then as to what exactly is displacement. But before we go there, here is a concept coming in here. Of course, initial. This is a very, very incredible concept worth discussing, Fanabos. Initial. So this initial has quite a lot of terms that we can use there. Because if we understand these terms, we understand our study of behavior of matter. We understand physics in Fanabos. And that is to talk about. Remember that we are saying we are talking about initial, but won't initial be synonymous with the origin? Because in actual fact, you come from home, you are going to school. That is what is happening here. Initial to final position. Displacement is only concerned about that. It's only concerned about your initial position all the way to your final position. So this is going to be, of course, initial or the origin. But another term that we can use, very, very important in actual fact, this term is, of course, the concept here called frame of reference, or reference point, frame of reference. So those concepts, we must be able to use them interchangeably to say what is a frame of reference, what is initial point, what is the origin. All those terms mean the same thing. So halala right now. So what is going to happen here now, you're going to realize something very weird then. And this is what is going to happen. There are streets in Sandton. Sandton is a very, very beautiful place to be in, of course. But for you to move from home to school, unfortunately, you just can't go straight and fly over houses with a lawyer. So what you can, of course, do is to walk around through the streets of Sandton. Walk around through the streets of Sandton until, of course, you get to your final position. So this then will be what we call distance. This is what we will call distance then. The distance being the total path traveled. So that will be the distance. Perhaps you went and you bought magwenya somewhere, you bought magwenya here. Displacement doesn't care about that. It doesn't care hey, there's a magwenya shop somewhere. It just cares about the initial point and the final point. Whereas the distance cares much about every step you took from the initial all the way to the position, all the way to the final position. Every step of the way, distance will account for that. Because by definition then, we say distance is the total, we say distance is the total distance traveled, of course, or it is the total path traveled. These are the type of questions that they ask, of course, in the examination. So for us to go through these questions, perhaps let's start by exploring, of course, the compass to say, well, never, ever smoke weed. That's the advice perhaps I could give you. I don't know why. But that's just, of course, to remember the compass. Never, ever smoke weed. Let us understand it in that perspective. Perhaps we will never, ever forget as to whether where is east, where is west. Just never, ever smoke weed. And we must be able to write the concept weed there. But this is not a platform to talk about such. So, halala right now. Now let's read the question. They say a boy walks in an easterly direction. So now that we understand our compass, we know that, of course, this means that the boy is walking to the right. There is the boy walking to the right. He's carrying his skateboard there. So after he passes a tree, he continues in the same direction for another 20 meters. He then stops, climbs onto the skate, and then rides in the westerly direction, meaning now he goes in this particular direction for 25 meters. He finally stops. Now you have to interpret this statement, of course. And the question they ask here is, the resultant displacement of the boy when he finally stops is 10 meters east of his initial position. Define the term distance. You have to know all your definitions by heart, and so 2.1, 3.1, 4.1 will always be about definitions. So try the activity here by defining the term distance, by determining the initial position of the boy relative to the tree, and then calculate the total distance that the boy moved. We will try to analyze the question once more, of course, in the next video. So for this video, please try to try the activity by yourself. If you want, you can even comment the solutions. I'll get back to you. So, and then of course the next video will start by talking about this activity, and then we will move on now to the concept of average speed, average velocity, and acceleration. So, halala right now. Welcome to Science Intellect Hub. My name is Mr. Mojaki Sanese. They call me Mr. M. Fanabo. So, halala right now.